Okay, so today you're going to be learning about Chapter 15. You can use your book if you need more examples or more practice problems. Here's some definitions you should know about Chapter 15. A random variable is a variable whose value is a numerical outcome of some random event. There's two types of random variables, discrete and continuous. So you need to be familiar with those. Discrete means that you have a set number of countable values. Continuous means that it can be any value in a given interval, and usually things that are measured, like height and weight and volume, blood pressure, all that stuff is continuous. So here's a quick example on determining if something is discrete or continuous. Letter A, the number of defective tires on a car, that's going to be discrete because you could only have 1, 2, 3, or 4 defective tires in a car. Letter B, the volume, that's something that you measure. So anything that you measure is always continuous. Letter C, the number of students on the Friday's absence list, that's again, it can be discrete because you can only have 1, 2, 3, 4, or 5 students absent. D, the home team score in a basketball game, that's also going to be discrete because you can only have certain values for depending on the baskets and the points that the team gets. Letter E says heights, so that's going to be continuous. And finally, letter F, anytime we do time, I guess for this class, it's just going to be continuous. So continuous. All right. So make sure you know how to do those discrete versus continuous. Use the textbook for more practice. Now, here's a lot of information you just need to know, a bunch of formulas, and we'll go through this in the examples. So here's the first real example on Chapter 15. Example 2. Let X be the number of daughters in a family with 3 children. Letter A. Create a probability distribution, or in other words, is also called a probability model for X. So we're going to make a probability distribution / model is a table. So we're going to do that on example 2. You always want to start by defining your variable. So the question already defined the variable, you still need to write it down. So X is the number of daughters in a family of 3 children. So let's just say X equals number of daughters. Please make sure you define the variable always. Now we're going to make a table of values for X. And we're going to list the possible values for X. So in a family with 3 children, it's possible that there are 0 daughters. So 0 would be one of the possibilities for X. And then I need to leave some space here to show some work. Or a family could have 1 daughter if there's 3 children. Or 2 daughters. Or 3 daughters. So that's when you want to start with. List the possible values for X, which was the number of daughters in a family of 3. And now for the second row here, we're going to put the probability of X. So you need to figure out what is the probability that a family has 0 daughters. So the only way for the family to have 0 daughters is if they had a boy, and a boy. So that's the only way for the family to have 0 daughters. So that's just going to be 1/2 chance times 1/2 chance times 1/2 chance. You're supposed to show your work, and that's equal to 1/8. So that's the first probability, 1/8. Now, when you do the 1 daughter, there's multiple ways to have just 1 daughter. Like it could have been the first child a girl, and then boy, boy, or it could have been boy, girl, boy, or it could have been a boy, boy, and a girl. So there's actually 3 ways to have the 1 daughter, but the best way to figure that out is to use a combination. So I'm going to do the NCR thing, the combination, and I'm going to put 3 total children, and I want 1 daughter. So that's going to give you 3, because there are 3 ways of having 1 daughter from a group of 3. And then after that, you just going to still multiply by 1/2 times 1/2 times 1/2. Because having a boy or a girl is just a 1/2 chance. So now when you do that, that gives you 3/8. Because the combination 3, 1, that's 3. So 3 times 1/8 is 3/8. And you repeat the process with having 2 daughters. There's 3 ways to have the 2 daughters, because you can think of it as like having a boy, girl, girl, or a girl, boy, girl, or girl, girl, boy. But instead of listing them like that, because they can be more complicated, we can still just do a combination. So I'm going to do an NCR of 3 comma 2, because again, there's 3 children and you want 2 daughters. So 3 comma 2. And then you're still going to multiply that by 1/2 times 1/2 times 1/2. Combination 3 comma 2 is still 3. So 3 times 1/8 is 3/8. And finally, the probability of having the 3 daughters, there's only one way for that to happen, and that's if they're all girls. So girl times girl times girl. So that's just 1/2 times 1/2 times 1/2. And that just gives you 1/8. One way to double check that you've done your probability distribution correct, when you add all your probabilities, it needs to add up to 1. If not, then you did something wrong. You missed something. So 1/8 plus 3/8 plus 3/8 plus 1/8, that is 1. So we've done that right. So that's how you would do letter A, and that's how you would do all of the probability models or the probability distributions. Always start with defining the variable, listing the possible values for that variable, and then show your work when finding the probabilities. Once you have that, the rest of the parts are going to be easier. So letter B, find the probability of having more than 1 girl. So basically I want the chances that X is more than 1. More than 1, because remember X was the number of girls or daughters. So more than 1 would be, you would have to add 3/8 plus 1/8, because those are the ones that are more than 1. So 2 or 3. So that's going to just give me a 1/2. And then letter C, find the mean number of daughters in the family. There's a formula for the mean. It's one of the things you need to know from up here. So the mean is equal to the summation of X times P of X. So what we need to do is we need to take every X value, multiply it by its probability, and then just add them all together. So my first X value is 0. Its probability was 1/8. My second X value is 1. Its probability was 3/8. My next X value was 2 with a probability of 3/8. And my last X value was 3 with a probability of 1/8. If you type that into your calculator, you'll get the mean number of daughters for this scenario, which would be 1.5. Which makes sense because if there's 3 children, on average, half of them will be girls, so daughters. So that's how you find the mean. You're supposed to show your work. And then to find the standard deviation, again, that's one of the formulas up here at the top. The standard deviation is, the standard deviation is the square root of the variance. So I'm just going to take the square root of this formula here. And the formula says, again, to do the summation, so we're going to be adding X minus the mean that I just found squared times the probability of X. So, okay, we're going to have to just do them all. So I'm going to do the square root of, okay, my first X value was 0 minus the mean is 1.5 squared times the probability of 0, so 1/8. Plus, okay, you're supposed to keep going, like the next X value is 1. So 1 minus 1.5 squared times its probability, so 3/8. Plus, okay, technically when there's a bunch of numbers, you can just put like dot, 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 and just show like 2 substitutions. So I already showed 2 substitutions, so I'm just gonna go dot, dot, dot for the rest, so we don't have to keep writing it. And now, you still need to, now you need to put that in the calculator. But there's some, I mean, we can do it by plugging it, by just doing them all on here. So 0 minus 1.5 squared times 1/8 plus 1 minus 1.5 squared times 8 plus the next x value was 2 minus 1.5 squared times 3, 8, and then the last x value was 3 minus 1.5 squared times 1/8 again. And that's the variance, and then you're supposed to take the square root of that to get the standard deviation. There you go, perfect. So that's the standard deviation. So it was the square root of 0.75, which was a variance, and 0.866, and then the units is supposed to be daughters. The units for the standard deviation are the same thing as the units for the mean, which is just the units for x. So that's how you're supposed to compute expected values, or the mean, and the standard deviation. Now, let me show you a quicker way. You still need to show your work. Well, I don't know how online work is going to go, but anyway, that's how you show your work for sure on the AP exam. And if it's, I guess, for response, we'll figure it out. But here's another way to do this on the calculator. It will do it for you right away. So here's how you can do it. In order to find that mean and the standard deviation that we just did, we could type in our data into a spreadsheet. So on a spreadsheet, I'm going to call it X, and then here I'm going to call it P for the probability. So remember the X values were 0, 1, 2, 3. And then the probabilities were 1/8, 3/8, 3/8 again, and 1/8 again. All right. So once you type it in the calculator, we can go and find the mean and the standard deviation by doing a menu, statistics, stat calculations, a one variable statistics, because we only have one variable, which is x. And then number of lists, just leave it as 1. The x list, I called it x, which was the number of daughters. And then here where it says frequency, you need to change that to, if you have to change it to the probability, or it's going to give you the wrong answer. So here I'm going to call it P, because that's what the probabilities were stored as, 1/8, 3/8, 3/8, and 1/8. I called them P. And then after that, leave it alone and press OK. And here's the 1.5, so x bar, that's the expected value slash the mean. It's right there. And then if you scroll down, there it is. That's the standard deviation. So 0.866, it's what we got when we did like the whole work. So now you know how to use the calculator to find the mean and the standard deviation. You still need to know how to do it like by hand, by just showing all your work. So that's example 2. Now example 3, go ahead and read the scenario. Okay, so we're making a probability distribution slash probability model. So again, that table. So you first start with defining the variable. So I guess we can say like y equals the total number of spots. Or you can say like the sum, I guess, of the two dice. Either one. Okay, and then the best way to do things with dice like that is to just write out the entire sample space. So one of the dice has the numbers 1 through 6. So I guess right here, 1, 2, 3, 4, 5, 6. So that would be one of the dice. And then the other die only has, 0 on 3 faces and then 1 on the other 3 faces. So the other die only has the number 0 and 1. So if you were to roll both of them, you're finding the sum. So I guess if you roll a 0 and a 1, that would be 1. A 0 and a 2, that would be a 2, and so on. So we're just finding the sums here. So 1 through 6 would be the sums if you rolled a 0 with any of those. And then the other sums over here, if you rolled the 1 with any of those, it would just be 1 plus 1 is 2, 3, 4, 5, 6, 7. So These are my possible sums right here. And it looks like the possible sums go from 1 through 7. So that's what I'm going to list for my y value here. Remember, you make a table. For the y, you list all the possible values for y. So you list all the possible sums, which I just said were 1 through 7. So 1, 2, 3, 4, 6, 7. And now for the second row, you're supposed to find the probability of each of those y values. So the probability of having a sum of 1, if you notice, is only 1 out of the 12 possible choices here. Or, yeah, 1 out of the 12 outcomes. So you put 1 out of 12. Rolling a sum of 2, there's 2 out of the 12 outcomes. Rolling sum of 3, just keep looking at that. So 2 out of 12. 4 is also 2 out of 12. 5 is also 2 out of 12. 6 is also 2 out of 12. And 7 is only 1 out of 12. Always double check that your probability adds up to 1, because then you kind of know you did it right. And that's how you do example 3. And finally, example 4, a discrete random variable x can assume 5 possible values, so 1 through 5. If the probability model is shown here below, find the rest of the answers. So first of all, it's missing the probability of x equals 3, but you should be able to figure out, because like I said, all these probabilities have to add up to 1. So if I just add all these and subtract from 1, you'll find out that this number is 0.3. And now we can start answering some questions. Letter A. Find the probability that x is less than or equal to 3. So probably that x is less than or equal to 3. You're supposed to show your work. So the way you would just show your work is you looking for the probabilities of x is being less than or equal to 3. So x could be 3, 2, or 1. So you need to add those probabilities. 0.3, 0.1, 0.2. So that's the probability of x equals 3, x equals 2, and x equals 1. Show your work. Add them all up. And that's 0.6. Letter B, find the probability that x is more than 2 but less than or equal to. Okay, so for these discrete random variables, it does matter whether you have inclusive or not inclusive, so just be careful. X needs to be more than 2, so technically it needs to be 3 or more, and less than or equal to 5. So since it needs to be more than 2, it needs to start with x equals 3, x equals 4, and then x equals 5. So then I'm just going to add 0.3 plus 0.25 is 0.15. And you add them all together, you'll get 0.7. There it is. Okay, letter C and D is just what I did on example 1. You have to find the expected value, which is the same thing as the mean. And then you have to find the standard deviation. Now, technically, you're supposed to show all of your work, including the formula. So the formula for the expected value / mean is always the summation of x times p of x. And now you're supposed to show your work. So x is 1 times 0.2 plus, we're just going to do dot, dot, dot. And then the last one I'm going to show is, you have to show 2 substitutions. I guess any 2 you want. I usually show the first substitution, then dot, 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 the last substitution. So my last x is 5 times 0.15. And then I'm just going to use a calculator to get that answer. I already showed you how to type this into a table. Call it x, call this p, and then just do a 1 variable statistics with x and p as your frequency. And if you do that, it's just going to give you what the mean is. It's 3.05. And then I'm supposed to have units, but I don't know what they are, so I'm just going to call it units. Same thing with the standard deviation. There's a formula, and the formulas are on the formula sheet that you get when you take the AP exam. So the formula is the square root of the summation of x minus the mean squared times p of x. So I guess my first x is 1 minus the mean squared times the probability of the first one was 0.2, dot, dot, dot. And then I can just do the last one. So 5 minus 3.05 squared times 0.15. Instead of, and again, I would just use a calculator with your 1 variable statistics to get the standard deviation. So that's going to be 1.3 0.322 units. And just like I did in example 1, go watch that if you want to see how to do it in the calculator again. And to finish the notes, letter E says, find the probability that x is within 1 standard deviation of the mean. So x needs to be within plus or minus 1 standard deviation from the mean. So first of all, let me just take the mean, which was 3.05, and I need to do within means plus or minus 1 standard deviation, so plus or minus 1.322. So when I do that, x needs to be from 1.728 to 4.378. So all I did was I did 3.05 minus 1.322 to get this number, and then I did 3.05 plus 1.322 to get that number. So x needs to be between 1.7 and 4.3. So technically, because these are discrete numbers, there is no 1.7. So technically, x has to be greater than or equal to 2, because that's the next number that's greater than or equal to 1.7. And it needs to be less than or equal to 4, because 4 is still less than or equal to 4.375. So it needs to be, x needs to be between 2 and 4. And in order to do that, you just add up the numbers when x is 2, so 0.1 plus 0.3 plus 0.25. And that gives you 0.65. One last question, letter F. Letter F is always the most missed every year in the quiz. I haven't even made this year's quiz, but anyway, just so you know, letter F is the most missed. So F, find the probability that x is more than 1.5 standard deviations away from the mean. So I still need to do the mean, so 3.05 plus or minus to find those boundaries more than 1.5 standard deviation. So 1.5 times the standard deviation, so 1.3 to 2. So this time it needs to be more than that much away from the mean, so it's gonna have to be less than 1.067, but more than 5.033. So the way I got those numbers, first of all, I just did 3.05 minus 1.5 times 1.322, and that gives me this lower boundary of 1.067. And then I did 3.05 plus 1.5 times 1.322 to get this upper boundary here. And now x is supposed to be more than that away from the mean. So technically, x is going to have to be less than or equal to 1, because that's still less than 1.067, or more than 5.03. It's going to have to be more than or equal to 6. You can't put 5 here because 5 is not more than 5.033. It needs to be 6, greater than or equal to 6. And that's what I think is the most missed. So it needs to be at least 6, because that's more than 5.033. Okay, so now if you look at your chart, you need x to be less than or equal to 1. So I guess the only one would be x is equal to 1, so 0.2. And then it needs to be more than or equal to 6, but there's no 6 there, so I guess 0, because the table only goes up to 5. So after that, there is 0. And that comes out to be 0.2. So now you have to go do your homework and practice. And like I said, use the textbook if you need some more examples, or if you need to do some more practice, do the odd questions and check the answers in the back of the book. Good luck.